Hello students, welcome to my YouTube channel Spiral Learning. This is my second lecture on CBSE Class 10 Chapter 11, which is taken from NCERT textbook. Name of the chapter is Electricity, and today's topic is Graphical Presentation of Ohm's Law. In my previous lecture, we know the mathematical expression of Ohm's law. So today we will start with the mathematical expression of Ohm's law. The mathematical expression of Ohm's law is V equal to Ri, where V equal to potential difference, which is denoted by Pd or abbreviated by Pd. I equal to current, capital R equal to resistance. Okay, so this is the mathematical expression of Ohm's law. For the graphical presentation of Ohm's law, we should know which is the dependent variable and which is the independent variable. Here V is the independent variable, and I is the dependent variable. Okay, what does it mean? If we increase the potential difference, the circuit diagram was like this. I am doing it with a small one. So this is the positive terminal, this is the negative terminal, potential difference is applied here. This is the A end, this is the B end of the conductor. Potential of A end is VA, potential of B end is VB. Okay, current starts to flow from higher potential to lower potential, and the current is denoted by I. Okay, so if we increase the potential difference, then obviously the current will increase. That we learn from Ohm's law, which states that V proportional to I. Okay, so V is the independent variable and I, that is current, is the dependent variable. This is IV and this is dV. Okay, now we know that the equation of a straight line which is passing through the origin, passing to the origin is y equal to mx. Actually, the equation is y equal to mx plus c. Since the equation is passes through the straight line, since the straight line is passes through the origin, so c becomes 0. Okay, so the equation appear like this: y equal to mx plus c becomes y equal to mx. So if we compare these two equations, suppose this is equation 1 and this is equation 2. So if we compare these two equations, then we see that by comparing equations 1 and 2, we have y equal to v, m equal to r, and x equal to I. So here is a question: what is m? M indicate slope of the graph, or slope of the curve. Okay, now let us draw a graph. This graph is also called the voltage current graph or VI graph. So this is x-axis, this is y-axis. Okay, so if we consider y equal to v, then along y-axis we will plot v, and along x-axis we will plot current I. Okay, now the equation will pass through the origin like this way. Okay, so it's making an angle of 45 degree. So this is the graph of Ohm's law, or this is the graphical presentation of Ohm's law. Okay, so how we can say that the graph is indicate the proportional relation of current and voltage. If we plot or consider 3 points, like one point is A, another point is B, and this is the point C, and try to draw a perpendicular from the point A on x-axis and y-axis, again from the point B to x-axis and y-axis, again from the point C to x-axis, and from the point C to y-axis. In each case, it will form a square. In each case, it will form a square. The length and the breadth both are equal. Okay. What does it mean? It means that V proportional to I. The amount of increase along V axis, the amount of increase along current axis or x axis are same. That's why it forms a square. Okay. So this is the graphical presentation of Ohm's law. So during examination or writing in the answer script, you need not to label like this way. You just simply draw the curve in this way. I am doing this only for examination purpose. Okay. X axis, this is y axis. You will plot V along x axis. This is the origin and current along x axis. And we will get a straight line which is passing through the origin like this way. Okay. So I am writing here this is the graphical presentation of Ohm's law. Okay. This figure is necessary to understand the proportional relation, and this figure is specially for examination purpose. Okay. Both are important, but the second one is important for examination. Okay. So now the question is, what we learn from Ohm's law? Graphical presentation of Ohm's law or VI graph. We can say the graph is a voltage current graph or VI graph. V hyphen I graph. This is very important in case of theory as well as in case of practical. This graph is basically a part of an experiment in your class 10 syllabus and in class 12 syllabus also. Okay. So the graph is a most important one, and I think it will be asked in your examination, because without the basic understanding of graphical nature of Ohm's law, you are not able to solve the question which are little bit complicated. So this is the basic knowledge of graphical presentation of Ohm's law. You should know it very well. Okay. So now what we learn from Ohm's law, or what is gives us Ohm's law, or graphical presentation of Ohm's law. The or what message we obtain from Ohm's law. Okay. This is the axis. This is x axis. This is y axis. I am plotting V, that is potential difference along x axis, and current along y axis. And we know the SI unit of potential difference is volt. So V in volt. And the SI unit of current is ampere. So current I in ampere. Okay, so let us draw a straight line passing through the origin. This is not a good one. Okay. Now I am going to draw a line from that point on the x-axis. Okay, and I am leveling these 2 points. This is suppose point A and this is point B. So it's a right angle triangle. Suppose this angle is theta. Okay, so this angle is theta. So from the triangle ABC, ABO, ABO, or you can write it AOB. From the triangle AOB, we have tan theta equal to perpendicular by base. Perpendicular is AB, base is OB. Okay. So what tan theta provide us? Tan theta basically provide us the slope. So here I am writing slope. Yes, slope, slope, colon tan theta equal to AB by OB. Okay. So AB is parallel to y-axis. Okay. So AB basically gives us the value of V. So in place of AB, I am writing V, and OB gives us the measure of current, that is I. That is V by I. And from Ohm's law, we know that V equal to R I, and then R equal to V by I. Okay. So this is basically resistance R. So this is resistance. Resistance. So what is the conclusion? The conclusion is the slope of VI graph gives the measure of resistance. Gives the measure of resistance. Or we can say the slope of Ohm's graphical presentation, or we can write it this way: the slope of the graphical presentation of Ohm's law Ohm's law gives us gives the the measure of resistance. Okay, so measure of resistance. This is very important. Slope of VI graph gives us the measure of resistance, or the graphical present or the slope of graphical presentation of Ohm's law gives us the measure of resistance. Okay, so this is the importance of proving of Ohm's law. Okay, so here we can make a heading: importance of VI VI graph or graphical presentation of Ohm's law. So this is the part which is very important. So let us sum up. First of all, we should know the mathematical expression of Ohm's law, which is V equal to Ri, where V is the potential difference and I is the current, R is the resistance. Okay, fine. And we putting this is as equation 1. Okay, so here I am drawing the circuit to analysis a little bit about the independent variable and dependent variable. Okay, so V is the independent variable because we can change the potential difference, and on the change of our potential difference current will be changed. So current is depends on potential difference, not potential difference on current. Okay, so I is dependent variable and V is independent variable. Okay, then we should know the equation of a straight line. Normal equation of a straight line is y equal to mx plus c, but when it passes through the origin, then c equal to 0 or c becomes 0. So that's why the equation becomes y equal to mx in the form of y equal to mx. The actual form of the equation is y is equal to mx plus c, and then from this equation we can reach here when c equal to 0. Okay, c is a constant, obviously in this case it is 0. Okay, the equation of a straight line which is passing through the origin is like this: y equal to mx plus c. Now we are doing a comparison between equation 1 and 2 for plotting the variables along x-axis and y-axis. Without comparison, it is very difficult to say that which quantity will plot in the x-axis and which quantity should be plotted in the x-axis or y-axis. Okay, so that's why it is very important to compare the quantities with the standard equation of straight line. So after comparing we find that, or we observe that y equal to v, m equal to r. What is m? M is the slope. M is the slope of the curve. Okay, and x equal to y. So now it is very easy for us to plot the variables of Ohm's law there are two variables of Ohm's law. One is potential difference and another is current. So here now plot V along y-axis and current or I along x-axis. As a result, we get a straight line which is passing through the origin, and for analyzing the proportional relation between V and I, we just draw 3 points A, B and C on the straight line. Okay, and we are trying to draw a perpendicular on x-axis as well as on y-axis from that point. Okay, these are the points. In each case, we observe that it forms a square. What is the meaning of this? Because along x-axis, the increase in x-axis and the increase in y-axis is same. When it will be same? When V proportional to I. So, this straight line will represent the mathematical expression or the statement or the mathematical relation between voltage and current or the potential difference and current. So this graph is indicated by figure 1. This figure 1 is important for understanding, or in some cases it will help you to solve some numerical problem or assertion reason question. Okay, now we draw the graph again, and in that graph we are plotting x along x-axis current and along y-axis potential difference or V. And I am writing here this graph is the presentation of Ohm's law. This is the graphical presentation of Ohm's law. Sometimes in examination it is asked through the graphical representation or presentation of Ohm's law. Then we will just draw the figure second figure without any hesitation. Okay. Now we are interested to know the importance of VI graph or the graphical presentation of Ohm's law. After drawing the graph and after some leveling, that is, we are considering a point on the straight line and draw a perpendicular on the x-axis, and after that we observe that it forms a triangle, and the triangle is a right angle triangle, so we can use the trigonometrical assumptions. So we are writing tan theta. Tan theta is the slope of the curve. But tan theta equal to, as you know, perpendicular by base, and perpendicular actually gives us the story of y-axis, that is the story of potential difference, and OB tells us the story of current. So we are writing in place of AB V and in place of OB I, and V by I from Ohm's law we know that V by I is nothing but the resistance. So we are writing R equal to resistance. That's all. Now the conclusion. The slope of VI graph gives us the measure of resistance. This is very, very important. The conclusion is very, very important. Okay, and we can say the same thing in other words. The slope of graphical presentation of Ohm's law gives us the measure of resistance. I think the video will help you a little bit. So thank you for today. Okay.